Live and all right, we're live. Howdy, Hacksters. Welcome to Friday. I thought I'd do some explainer videos that I'm going to call FYI. And this is just going to be a quick video that's going to talk about the difference between these acronyms SMD and SMT and what they actually mean. So, you might have heard of SMD LEDs or whatever. This just means surface mount. And we have two acronyms. One of them is SMT, that stands for Surface Mount Technology as a whole, the whole idea that you're able to mount components on the top of a surface, on the surface of the PCB, the PCB being the printed circuit board, and we have an explainer for that one already, actually. You see how on the back of this board, there's some foam tape, but what you don't see are any components or any little legs of components sticking through, compared with this other one, the 555 timer kit from Evil Mad Scientist Labs, which has a bunch of little legs sticking out on the back, and you can see where it was soldered. So surface mount technology, this is through-hole technology. There's holes in the original PCB here, and we've stuck components through and soldered them on with a soldering iron. By contrast, this surface mount technology on this Circuit Playground Express from Adafruit, everything is mounted on the surface. So SMT stands for Surface Mounted Technology, and SMD stands for Surface Mount Devices. So things like LEDs, transistors, resistors, and things like that, a lot of these come in packages that sit on top of the surface of the LED, and instead of soldering them with a soldering iron and sticking them through the board, instead you solder on top. And we're going to take a look at how that's done. Usually it's done with solder paste. Let's take a look at these resources I've pulled up. Or actually, first, let's take a look at these real live things that I have right in front of me. Yeah, so here we have a relay module from Seed, from their Seed Grove system. And this is the relay right here. Inside here is a little solenoid, incidentally, that makes the connection between the two, your contacts. But I thought this was cool because it demonstrates both of them at the same time. You've got these tiny little surface-mounted transistors and LEDs and things in here. And then you also have some through-hole components. So you can see on the back of the board, here's where the relay is going through, the little legs are poking through. Here's where that terminal, that screw terminal is mounted. And then here is where the Grove connector is mounted. And all three of those have legs that go through the board and were soldered on the bottom of the board. However, these little components here just sit on the surface of the board. They're surface mounted. And the silver stuff over here, of course, is solder. And the silver stuff on either side of the components here is also solder. And what we can see here are, we've got a transistor, this little three-legged guy here. We've got an LED here. It's labeled D3. LEDs are typically labeled with a D, standing for diode. You've got, the transistor is usually labeled with Q for some reason. I think because T maybe already meant something else. R3 is a resistor. You've got another diode here that's a regular diode. So that's D1. And then a couple more. I think there's a capacitor there, C1. And it's a little hard to see, but that's because it's very small. All right. So then I also have, when you get surface-mounted components from a supplier, typically they will come on a roll like this. So these will be on reels. And if you are doing more of an industrial project, you might order an entire reel of these. So these are little LEDs, individual LEDs. And to remove them from the reel, I have just pulled up this plastic covering. And if you're doing it in an industrial setting, typically, as I said, you'll have a whole reel of them. And there'll be a machine called a pick-and-place machine that automatically peels back this plastic tape, removes the components from the reel, and then places them, or it picks them, you could say, from the reel, and it places them on your board, and then it does all the soldering as well, which actually involves some steps before the pick and place, but we'll look at that in a second as well. Okay, so now that we have a little, oh yeah, another quick example. Here's the Arduboy, a really beautiful device, which has all surface mount components. Actually, I think there might be a connector for the screen that goes through. But all these little guys with their legs out to the side, these little chips and transistors and things, They're all surface mounted. It's beautiful. Oh, you know what? I think this USB guy goes through, and that makes sense because it needs more physical reinforcement. So you can see these legs kind of feed into little holes in the board. Everything else is mounted on top. It's the arty boy. All right, so now we're ready to go to the internet. Dive into the information superhighway. Information superhighway. Tried to make a cool old school reference, but my brain is a little bit Friday right now. Oh yeah, Habib says that 555 ICT looks brilliant. This is really cool. This is the discrete 555 timer, aka the 3 5s kit from Evil Mad Scientist, and it takes a little 555 chip, which is just an 8-pin electronic IC integrated circuit, and basically blows it up. So instead of being a tiny little package with 8 legs, it's you physically solder together all the components that are inside the chip at like a blown up size so that you can see what's going on inside of there. It's so cool. I love it. And it's just stylish is all get out. I think this was a collaboration as well. So check that out. Anyway, Evil Mad Scientist labs, they're so cool. So let's take a look at the internet. We've got I found a post on the Seed Studio blog that tells us about the difference between SMT and SMD. So SMT, as I said, is surface mount technology, and SMD is surface mounted devices. Here they have a really cool diagram of the workflow in an industrial setting for how you would do surface mounting. So for example, first you stencil solder paste onto the PCB. And I actually have an example of doing this by hand without the pick and place machine. Oh yeah, so first you'd put the solder paste down, then you do the pick and place mounting of components onto the board. Then you put it through a heater, basically. You pass it through an oven that heats up that solder paste and turns it into melted metal. And that creates the solder connections, and all the metal, the solder sort of slurps onto the pads of your circuit board, and it looks really cool. And I've got that in the video we're going to look at in a second. And then sometimes you have this automatic optical inspection setup. Some people trust them, some people don't. It can be a nice way to catch really blatant errors early on. There's some things like tombstoning that can happen when your components sort of slide into place when the metal solder is heated. Sometimes one end will flip up, and that's a pretty common problem with using reflow ovens, and you can detect things like that. So we have a really cool PCB that Gustavo Reinaga designed called Oshui, and it is a sort of octopus squid. I think it's an octopus, but it's got some blinky RGB LEDs on it. And you can see this video I've linked in the description below of the entire process of doing this by hand. So first up, here's our components. Then we take the board under here, and I have a stencil. I guess it's hard to see the board, but there's a stencil laid on top of the board. You put some solder paste down. That's solder in a paste form. And then I'm lining up the holes in the stencil with the pads on the PCB, the circuit board. And then you squeegee it through the solder paste, through the stencil. And then in that way, it applies a thin layer of solder mask to all of your pads. This was not a super smooth job. It's been a while since I last soldered. This is from 2 years ago. But look, now you have a beautiful layer of solder paste. Well, mostly beautiful. I had to do some touch-up on those pads. You can see me applying a little bit more solder paste to a couple of pads just using tweezers. And then you place the components on top. A machine would do this with a pick-and-place machine if you're doing it industrially, or if you're just doing a few prototypes, you can place these things. I think that's a little capacitor. I've got some LEDs on there. And we've got all those things on. There's some little techno music behind this as well, I think, if you want to watch the actual video. So you place all these things, and then you get to the money, which is I placed it on a heating hot plate, basically. And you can see all those little shiny things that are happening. the dull gray solder paste is melting and turning into shiny silver solder connections. It's a little hard to see on this one, but it is so pretty when it happens. This is a really accelerated video as well, but if you watch it close up, oh, it's so satisfying. I didn't get any tombstoning on this one, which is pretty nice. And then you can see the contrast about mounting them by hand. I also did the other side with an actual soldering iron, I think, just to make it a little bit easier on myself. And because I didn't want to damage the other side of the PCB. So here I'm soldering surface mount LEDs by hand with a soldering iron. Note that even though I'm doing it with a soldering iron, all the components are sitting on top of the surface of the PCB, and so it's still surface mount. All right, there's a great Wikipedia article about surface mount technology, and it talks again about surface mount technology is the T, surface mount devices are SMD, and oh yeah, there's BGA, ball grid arrays. Oh, that's another good video idea there. On the Wikipedia pages for LED lamp, you can find a comparison of common SMD LED modules. I don't think that's too interesting, but it could be if you're into a rabbit hole. And then just contrasting, like, so we're used to looking at LEDs like this, right? If you're a newcomer to electronics, you're probably pretty used to seeing them like this. And you would poke the LED through the circuit board, spread the legs apart so that it stays in place, and then flip the circuit board over and solder it with your iron. Surface mount LEDs look more like this, where you have the pads sort of on the bottom, which can be really frustrating, but often they like poke out to the sides here, so it's not too bad to do with a soldering iron. I showed you also some in a reel a second ago. Oh, there's a cool thing about those actually. Let's take a look. Okay, so if I take one of these out, actually I'm going to take one of these so I don't lose one of the ones I really care about. Often you'll find that they have I really wish I had tweezers right now. Now here we go. Trying to get just one of these. Okay. On the back of them, they have a little green symbol, and typically that will point towards the ground contact. So in this case, I think it's more of a green stripe. So probably this side is ground. Let's flip it over. Sometimes they have an indicator on the top side as well. This one does not. Sometimes they'll have a little dot on the top side showing which side's ground. Yes, you can use a heat gun for soldering the SMD components. However, I've found it annoying because when you're doing it with a heat gun, you're melting the metal, and at the same time, you're trying to... So there's no other adhesive holding the components in place on the board, right? You've only got this solder paste, which is not technically an adhesive. It just kind of helps the pieces stick to the board for a moment until you melt it and really solder them in place. So you still have to be kind of gentle when you're moving the boards around so that the pieces don't fly off. And when you're using a heat gun, you can accidentally blow some of the pieces off the board, the components. It is not that common, but it's annoying enough. And also I've had trouble getting the heat gun up to like a proper heat for soldering things and getting an even distribution of temperature. So, you know, one trick that you can do is use a hot plate on the bottom of the circuit board. Put your, a hot plate, put your circuit board on top of there, and then you have the hot plate at a lower temperature than the solder melts, but still fairly high, and then you use a heat gun on top of that so that you can sort of spot heat it to the higher temperature required to melt the paste. And then you're able to sort of keep the whole board at a temperature that's safe for your chips and things that are more temperature sensitive, but at the same time be able to sort of spot solder those, apply heat selectively to different parts of the board. So let's go back to the internet. I also wanted to show you a comparison between through-hole and surface mount transistors. So if you've worked with transistors, you'll often see them in this kind of a shape, or that kind of a shape, either with the legs straight out or with them a little bit moved out to the sides. And surface mount ones typically have 3 little legs, and they look like this. They look like little bugs. They're so cute. And again, those will be typically labeled Q on the schematic or on the PCB. And LEDs will be labeled D, D1, D2, D3, etc. Capacitors C1, C1, 2, C3. We looked at the OSHWI soldering videos. These link to each other. There's also a Wikipedia article on Throughhole Technology if you just wanted to compare the two and aspects of each. There's also an interesting blog post that I'll put in the description from Optimum Design that talks about other acronyms that relate to this technology. It says, there are perhaps too many terms that describe different aspects of surface mount technology. Here's what they all mean. SMA is surface mount assembly. SMC is surface mount components. SMD devices. SME equipment. SMP surface mount packages. Yeah. But, you know, if it starts with SM, it's probably to do with that. There's some other cool acronyms in here. But yeah, finally, another thing relating to through-hole soldering. So you know how we looked at the workflow for industrial surface mount soldering, how you start with applying the solder paste through a stencil, then you do the pick and place mounting, then you do the reflow soldering, which is basically an oven, and then you sometimes have the optic inspection. Well, for through-hole industrial soldering, there's a really cool machine called a solder fountain. And it sounds like the most dangerous, like a chocolate fountain, but for solder, and that's basically exactly what it is. So here, I found a video that I've linked below about demonstrating one of those machines. And so one thing I haven't seen before is that they're foaming the flux. They apply the flux to the circuit board to make the solder adhere well and flow well. Using an air stone? I don't know what that is, but they foam the flux and then they run the board over it. And then later on, basically you have this little fountain of molten solder, which is probably like lead and tin. And it's just spilling out over these little walls on here. And this also actually has a pretty killer soundtrack. There's a great little chiptune type audio file going along with this. And then you pass the board over it. And so all those places where components have their legs stuck through the board, on the bottom of it, there's been flux applied. And then the molten solder runs over the joints and just adheres to everywhere there's pads and component legs. Isn't that cool? It's so cool to look at. Just this bed of molten metal. It's extremely metal. Anyway, so that's a solder fountain. And you can kind of see how this stuff, I think it's called scurf or something, is accumulating on the surface of the molten solder. I'm assuming they have systems for that. But yeah, very cool. So that has been the difference between SMT and SMD. Check out the links in the description of the video if you'd like to learn more. And if you have suggestions for future explainer videos, I'm especially focusing on acronyms because I think that those are things that I have to like remind myself about from time to time. Things like, you know, what is SPI versus I2C versus UART, things like that. We're going to have a bunch of those. And yeah, feel free to drop those in the comments. I'd be happy to indulge you. And yeah, have a great weekend and hack on. Ooh, Habibi says, thanks, I used one time a clothing iron and it actually worked. For surface mount soldering, whoa, cool. I'm guessing maybe on the bottom. Anyway, that's pretty rad. Have not tried that. If you try it, let us know your results. Awesome. Have a great weekend. We'll see you soon.